Hi everyone. All right, in this video I want to go over sample exam number 4A, the detailed solution, and show you also, mostly we're gonna solve this by using the calculator so you can get familiar with that. All right, check the problems one by one. Okay, problem number one, find the number of successes X suggested by the given statement among 1,450 randomly selected car drivers in one city. 7.52% said that they had been involved in an accident during the past year. So number of success is just X, and X is P hat times N. And we know this formula comes from P hat is X over N. So basically you just isolate X and change the percent to decimal point 0.0752 times 1,450, you get 109.04. It's better to round it because number of people cannot be decimal. So it's 109 and C is the answer. Number two, compute the test statistics used to test the null hypothesis P1 equals to P2. So x1 is given, n1 is given, x2 is given, and n2 is given. The test statistics when the claim is about the difference of two proportions is p hat minus p1 minus p1 minus p2, and this was p hat 1 minus p hat 2. And this is always 0, again assumed in HO, over square root of p bar, it's not p hat, be careful, times q bar over n1 plus p bar times q bar over n2. Now the formula for p bar is x1 plus x2 over n1 plus n2. If you substitute those, you get 0.354. Q bar is 1 minus p bar, 1 minus 0.354 is 0.646. P hat 1 you can calculate by doing x1 over n1, and p hat 2 you can calculate by doing x2 over n2. So all you need to do is to substitute all those numbers and use your calculator, and you get 0.159. So next one, it's information about movie ticket sales was printed in a movie magazine. Out of 50 PG rated movies, 45% had ticket sales in excess of $3 million. Out of 35 RX rated movies, 27% grossed over $3 million. So here, same question. We have to find the test statistics. It's like number two. So here, N1 is given, N2 is given, P hat 1 is given, and P hat 2 is given. So X1 is N1 times P hat 1, and X2 is N2 times P hat 2. You can get those numbers. So it's 23, and X2 is 9, and you can use the same formula. Find it and substitute, or with your calculator, you can go to stat test to prop z test and just substitute x1 n1 x2 n2 and just say calculate, and the calculator is going to give you this answer, and it's very close. Always take the closest answer, or you can do the hand calculation, get the same thing. But then if you do that with your calculator, the test statistics is that, and for this problem it's always take the closest one, and the reason why it's different because of the decimal point. So B is the answer for this question. Use traditional method of the method to test a given hypothesis. Assume that the samples are independent and they have been randomly selected. So here the claim is given. Use the given sample data, test the claim P1 is greater than P2. And of course, alpha is 0.01. So if you write the claim, the first claim is P1 greater than P2. So that's our original claim. And so HO is going to be P1 equals to P2, always. This is a right-tail test. To find the critical value, you can go to inverse norm 0.0101 and do not divide that by 2. It's just one tail. You get negative 2.33. But you take positive 2.33 because it's a right tail test. Now the test statistics, same thing. You can use this formula p hat 1 minus p hat 2 minus p1 minus p2, which is 0, over p bar times q bar over n1 plus p bar times q bar over n2. Calculate p bar by substituting the givens x1, x2, n1, n2 are given, so you get that. Q bar is 1 minus p bar, so you get that, and just substitute the givens in the formula, you get approximately 2.66. And you can use your calculator for that. And let me share the calculator for this example so you can see how that works. Let me bring the calculator up and so let's see here. So the first step, we go to stat and we go to test and you scroll down. This is 2 prop z test again. So let's put the givens. X1 is given to be 38. N1 is given to be 85. X2 is given to be 23. And N2 is given to be 90. And of course, the problem said P1 is greater than P2, so enter that. And you can calculate, so 2.6571, so that's what we get, we said 2.66. And you have also the p-value, which is 0.003, and let's go make the conclusion. So let me, so we got 2.65, or I can say 2.66 here, which doesn't make a difference. So it's in the shaded region. You're going to say reject HO. That's the first one. So we're going to reject that and accept that. Reject HO, or then you go to where it says accept the original claim. So we know we have enough evidence to support the original claim. And I have the solution from the test bank here. You can double check your answer. Number 5. In a random sample of 360 women, 65% favored stricter gun control laws. In a random sample of 220 men, 60% favored stricter gun control laws. Test the claim that the proportion of women favoring stricter gun control is higher than the proportion of men favoring stricter gun control, and use alpha to be 0.05. Now the given was the givens are N1 360 and P hat 1 65%, N2 220 and P hat 2 60%. When X's are not given right away, find the X's. So X's are going to be X1 is 360 times 0.67. That's 234, and x2 is 220 times 0.6, which is 132. Let's write the claim. The claim says that P1, P of women is greater than P of men, which is P1 is greater than P2. And of course, HO, they're always equal. So this is again a right tail test. To find the critical value, you do inverse norm 0.0501, you get negative 1.645, but take the positive one because it's a right tail test. And to find the test statistics, I just did the calculator here. Same thing, you go to stat, test, number 6, 2 prop z test, put the givens, type the givens, x1 234, n1 360, x2 132, and n2 is 220. And just calculate. The calculator is going to give you z to be 1.21, and that's the test statistics. And p-value is 0.13, which is much greater than 0.05. Use one of them to make the conclusion, and 1.21 is right here in the 9 shaded region. So the first conclusion is fail to reject HO. Fail to reject HO, that means you accept HO and you reject H1. Then you go to your OC or the original claim, it says reject. We are rejecting the original claim, so not enough evidence to support the original claim, or the claim that says the proportion of women is greater than the proportion of men. You can use the formula also, but calculator will do that to you. And I have the solution here. Let's read the solution. Failed to reject the null hypothesis. We got that. There is not sufficient evidence to support the claim that the proportion of women favoring stricter. So favoring stricter gun control is higher than the proportion of favoring stricter gun control. So number 6. Test the indicated claim about the means of two population. Means. So assume that the two samples are independent and they have been randomly selected. So the requirements are given here. Two types of flares are tested for their burning times in minutes, and the sample results are given below. So we have brand X and brand Y. I call them 1 and 2. N is 35, X bar is 19.4, and S is 1.4. N is 40, X bar is 15.1, and S is 0.8. Remember here, so this does not assume that sigma 1 equals to sigma 2. So we know this is gonna be a t-test, but here we're gonna use pooled or not. If the problem does not mention that they're equal, so equal to sigma 1, it's not mentioned in a problem, so we're gonna assume that they're not equal. Therefore, we're gonna use not pooled. So we're gonna say no to pool. And again, put the givens n1 x bar 1 s1 n2 x bar 2 s2, and alpha is 0.05. Since it's a t-test, we are gonna use we have to get the degrees of freedom. In this case, it's not pooled because sigma 1 is not equal to sigma 2. So the best degrees of freedom is the smaller of n1 minus 1 or n2 minus 1, which is going to be that one. 35 minus 1 is 34 because 35 is smaller than 40, obviously. The claim mu1 equals to mu2, and because the problem said that they have equal means, and that's our original claim, and h1 mu1 is not equal to mu2. So to find the critical value, that's a t-test. So you go to inverse t 0.025. To tell, you have to divide it by 2. Degrees of freedom 34, you get negative 2.03. It's right here. And on the other side, of course, is going to be positive 2.03. Test statistics. This is the formula for test statistics, and I did that for you. So If you substitute all the givens, this is always 0 assumed in HO. So you get 16.025. Calculator, you go to stat, test again, number 4, 2 sample t-test. The calculator is going to ask you pooled, yes or no. It's no because sigma 1 is not equal to sigma 2. The problem did not mention anything. So we assume they're not equal. And I put it for you, highlight no for pooled. So let's go make the conclusion. The test statistics is 16.025. Reject HO is in the shaded region. So you write reject and you write accept here. We are rejecting the original claim. So not enough evidence to support the original claim or to support the claim that says the means are the same. So, and you can check the solution. Let me just read this solution. There is sufficient evidence to warrant the rejection of the claim that the two population have the same means. So here it says we have enough evidence to reject that they have that, well, which is the same thing. We have enough evidence to reject the original claim that says they have equal means. The next one, number 7, the two data sets are dependent. Find d bar to the nearest tenth. So you have A and B. So d bar, when you hear d bar, we're dealing with matched pairs here. So this could be before and after. First, what's the formula for d bar? Sum of these over n. It's just the mean of the differences. So if you want to find this, and I want to go over this by using our calculators, first we can find let's find the differences by using our calculator. So let me share the calculator here. So first thing you want to do, go to stat, edit, and let me clear all those lists. So then you can input in L1, put A's, or in this case, you can say before. So let me enter that. We have 56, then we have 59, then we have 55, then we have 63, and we have 51. In L2, you can put the B's, which is 27, and 25, and 21, and we have 25 again, and we have 22. So let me just double check 59, 25, 55, 21, 63, 25, and 51, 25. So that's correct. Now, if you want to find the differences, there's a fast way of doing that by using the calculator. So go to L3, and for L3, just type in L1, that means second function 1 minus second function 2, which is L2, and just enter. So the calculator can calculate that. Now, if you want to find the mean of that, you want to find the mean of the differences. So go to stat and go to calc and one bar stats, enter. Be careful, the list is not L1. The differences is on, they are in L3. So just do second function 3, which is L3. We don't need the frequency list because it's only one list here, and enter. So X bar is the same thing as D bar for the calculator, which is 32.8. So let's go back and check. So 32.8 is the answer, and I put all the steps for the calculator for you. So you can go over these steps, whatever I just showed you, and you can get the answer. Number 8, S sub D. This is the standard deviation of the differences. The differences between two sets of dependent data are 321, 327, 15. So we have to find S sub D. So round it to the nearest 10. The formula for S sub D is just the same thing as the formula for standard deviation. But with your calculator, you can go to stat, edit, put the differences. These in L1, then go to stat calc, one more stat. So step number 7, you're gonna see S sub X is the same thing as S sub D for this calculator. And if you do that, you get 10.7, so B is the answer. Next, number 9, assume that you want to test the claim that the paired sample data come from a population for which the mean differences is mu sub d equals to 0. Compute the value of the test statistics. So we have x's, we have y's, and of course the differences are going to be x minus y. The test statistics, the formula is given by d bar minus mu sub d, which is always 0, over s sub d over square root of n. Now here you can calculate the differences, put them in the calculator. In L1, find d bar, find s sub d, and just substitute, and you can get the answer. Or you can just go ahead and do that fast. So let me go over these steps. Go to stat, edit, put the x's in L1 and the y's in L2. For L3, I just showed you for the last problem, write L1 minus L2. The calculator is going to right away calculate the differences. Then go back to stat, test, go to t-test, because that's a simple t-test. And you can pick data in this case. And your data are the differences that the calculator that. So therefore, for mu0, you put 0. For the list, you put L3. Be very careful. And you pick mu not is different than 0, which is mu0. So, and then if you do that, the calculator will give you this answer, negative 0.523. So C is the answer. So one more time, follow these steps and you can get that very fast without calculating d bar and ST. If you go directly to data, the calculator does the testing for you and gives you the value of the test statistics right away. So try that and see. Number 10, use the traditional method. Traditional method stands for the test statistics only. You don't need p-value. Of hypothesis testing to test a claim, to test a given claim about the means of two populations. Assume that the two dependent samples have been randomly selected from normally distributed populations. 5 students took a math test before and after tutoring, and the scores are there. So we have the subject, 5 students, A, B, C, D, E, before and after scores. Using 0.01 significance level test the claim that tutoring has an effect on math scores. So now when it says has an effect, be very careful. The effect can be negative or positive. It doesn't say if it's effective or not effective. Has an effect, we don't know if it's positive or negative. So when you write the claim, you're going to write mu sub d not equal to 0. If mu sub d is not equal to 0, that means it has an effect. And here we don't really want to know positive or negative. So that's why that's the claim. HO is mu sub d equals to 0. So here no effect. And if this claim takes over, then has an effect. So if you want to do the testing, first of all, the critical value you do inverse t because it's a t-test, 0.005 2 telled, you divide alpha by 2. and degrees of freedom are 4. It's 5 minus 1, 5 student minus 1, and you get that number. So you put negative and positive. Test statistics, you can use your formula for that. Or if you want to do this directly by using the calculator, so you can go to stat, and let me do that for you. For problems like this, let me share the calculator. So let's clear that. So you go to stat first, edit, and let's clear this again. So you enter the befores in L1. So we have 77, then we have 69, then we have 66, then we have 72, then we have 69. And the after scores in L2, 81, enter 69, and it's 78. So let's go out, that's 78. And we have 64, we have 75, and we have 81. So let me just double check. 77, 81, 69, 78, 66, 64, 72, 75, and the 69, 81. Then you can go to L3, and for L3 just do second function 1 or L1 minus second function 2 or L2 and enter. So the tutoring, the calculators give you the differences. So for the first student, it had a negative effect, because it has a positive effect because the difference is negative. So that's an improvement. The second student improved, so that's negative. The third student got less than the first test on the second exam. So the difference is positive, not effective, negative effect. And the third and the fourth one, they both have positive effect because the difference is negative. But that's not the calculator. The problem says if it has an effect. So let's go test it. So you go to stat again, go to test. This is a simple t-test. And you can put amp, you can pick data here. So enter data. Mu sub d is mu sub 0 here. And you are testing the data, the differences that are in L3. Be very careful and pick the test, which was the first one, the claim, and just calculate. So negative 2.13. Let's go make the conclusion now. So I put all the calculator steps here. You can follow this and redo this problem, and the calculator will give you, we saw, so it's negative 2.13. That's in the non-shaded area. So first conclusion, failed to reject HO. Failed to reject, that means accept HO. And we're gonna, of course, reject that, but let's look at it. We're accepting the claim that the tutoring has no effect. So the conclusion is the tutoring has no effect. So number 11, let's see, the table below shows the weights of 7 subjects before and after a particular diet for 2 months. So we have the subject, we have the weights before and the weights after. So use 0.01 level of significance test to claim that the diet is effective. Be very careful here, it says effective. So the diet was effective for the first person because the difference is positive, and the diet was effective for the second person because again the difference is positive, and so on. So if you want to write the claim, H1, or you say mu sub D is positive. If this claim takes over, then we can say this diet is effective for the population. So this is to find the critical value. And again, of course, mu sub D equals to 0 in this case. And if this takes over, that means the diet is not effective. Inverse T 0.01, so because it's one tail and you put 6, the degrees of freedom is 7 minus 1, which is 6, and you get negative 3.143. So you take the positive one because it's a right tail test. Test statistics is the same. You can find those values by using your calculator and substitute, or just like the last problem, go to stat, edit B's befores in L1, A's in L2. Then step number 4, go to L3, do L1 minus L2. Go back to stat, test, and it's a t-test. Pick data. Your data is in L3. Don't forget, and I put it for you. The value in the claim is mu sub d 0. And pick L3 and pick the third claim, which is mu 0 greater than 0. And the calculator will give you this answer, 1.954. Let's make the claim. 1.954 is before 3.143, so it's in the non-shaded region. Failed to reject HO, accept HO, that means accept that the diet is not effective. So the diet, you can put the diet is not effective, or if we just read the solution here. There is not sufficient evidence to support the claim that the diet is effective in reducing weight. So the diet is not effective. Number 12, a test for abstract reasoning is given to a random sample of students before and after completed a formal logic course. The results are given below. At the 0.05 significance level test, they claim that the mean score is not affected. Again, it doesn't say effective or not effective. Not affected or does not have an effect. You use this claim. So mu sub d is not equal to 0. If this takes over, then we know that it's affected. And if mu sub d is 0, then it's not affected. So now let's go and the critical values. This is a two-tailed test. So you take 0.05 divided by 2, it's 0.025. The critical value is inverse t 0.025. Degrees of freedom are 9. And if you do that, you get negative. So here you get negative 2.262. 2 point, so negative 2.262. So you know it's going to be negative here and positive there. The test statistics same way. You can use the formula or you can go directly to your calculator. Stat edit befores in L1, afters in L2, L3 is L1 minus L2. Stat test, it's a t-test, peak data, and we all know this by now. The list is L3, and you pick this claim, the first one, and T will be 2.366. Let's make the conclusion. 2.366 is after 2.262. So you say reject HO. Reject HO. That means you reject that and you accept that. So you accept the claim that says it's affected. So you can write is affected. Now you can read the solution. There is some sufficient evidence to warrant rejection of the claim that the mean is not affected by the course. So we reject that. is not affected, but we said it's affected. So next one, number 13, construct confidence interval for mu sub d, the mean of the differences d for the population pair data. Assume that the population pair differences are normal distribution. You're given d bar, s sub d, n, and 99% confidence level. The formula mu sub d is d bar minus e and d bar plus e. And the formula for e is given here. So you can find those numbers. T sub alpha over 2, you can use your calculator for 99% confidence level. You S sub D is given and you have, and you can substitute. Or if you want to do this directly, go to your calculator. Stat, test, this is a T interval. So you do T interval, then number 4. So for X bar, if you go T interval, so you pick stats. So in this case, because data is not given, you're given D bar. D bar is the same thing as X bar. So you substitute 3.125. S sub X is the same thing as S sub D, 2.911, and N is 8. And the confidence level is 0.99, and you just say calculate, and the calculator will give you this result. And B is the answer. Number 4 is the same type of problem. Here you are given the data. The table below shows the weights of 9 subjects before and after following a particular diet for 2 months. So you have the table, construct 99% confidence interval for the mean difference of the before minus after weights. So this is the confidence interval, d bar minus c and d bar plus c. Same thing. D bar is T sub alpha over 2 times S sub T divided by square root of N. You can calculate, first you can calculate the differences, then go to 1 bar stat, get D bar and S sub D and use the formula. However, you can do this directly. Go to stat, edit, B's in L1 and A's in L2. So then one step I missed here, what you can do. So let me complete that for you. So actually we can put it, let's do 5 here, 6 here, 7, 8, 9 here, but let's put 4 in here. We miss, you have to do L, go to L3 and say L3 is L1 minus L2. So then you go, when you go to T interval, pick data, and the list you have to pick L3 and confidence level 0.99. And if you do that, you're going to get this answer. A is the answer, negative 0.6 less than mu sub D, less than 20.4. So please take a look at this and redo it yourself. You'll see it's pretty straightforward. Use the number 15. Use the traditional method of hypothesis testing to test a given claim about the means of 2 populations. Assume that the 2 dependent samples have been randomly selected from normally distributed populations. So we have all the assumptions here or requirements. 10 different families are tested for the number of gallons of water a day they use before and after viewing a conservation video. At the 0.05 significance level test, they claim that the mean is the same before and after viewing that video. So is the same, that means that's the claim. So of course H1 is going to be, is not equal to 0. That's a two-tailed test. Critical values, again, alpha divided by 2, its inverse t 0.025. Degrees of freedom are 9 because it's 10 families. 10 minus 1 is 9. So you get that put the negative here and the positive here. The test statistics, same thing. So, and you go stat edit B's in L1 and A's in L2. And again, I missed that step. So one step you can say you go to L3 and you say it's L1 minus L2. So calculator will do that to you for you, and go to stat test t-test data, and the list is L3, and you just say calculate. Let me do this one for you so you have an idea how that works. So share the calculator. So let's clear that. So you go to stat edit first, and let's clear all those lists. So let's see, it's 33 in L1. We put 33, 33, 38, 33, 35, 35, 40, 40, and 31. Now in L2, we put the after. So it's 34, 28, 25, 28, 35, 33, 31, 28, 35, and 33. I think one's extra, but let me double check. So we have 33, 34, 33, 28, 38, 25, 33, 28. We have that 35, 35. We have that 35, 33. We have that 40, 31. We have that. Then we have 40, 28. Then we have another 40. I missed another 40 here. That's not a problem. So you put 40, another 40, and 35. And finally, we have 31. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once you do that, you go to L3. So highlight A3 and just say L3 is second function L1 minus second function 2 or L2. You enter. So you have the differences. So once you get that, you go to stat, you go to test, and that's a T interval number 8. Pick data because the data is in L3. Make sure to put L3, so second function 3 here. Frequency is good, and the confidence level was 0.99. Actually, this was, I'm gonna correct myself, enter. You can get the confidence level. The problem was testing, but that's fine. It's the same thing. You can go to test, you can go to t-test, and again, pick data. Mu0 is 0, that's mu sub t. The list is in L3, so we learned about that, and it says it didn't make a difference, so it's not equal to. Then you can calculate. And 2.89 is the test statistics, 0.00177 is the p-value. So again, the problem was, as for testing, I did the interval 2, which should be quite all right. So now let's go make the conclusion. So again, 2.89 894 was the test statistics, is in the shaded region. So reject HO. We are rejecting and we are accepting H1 or accepting that mu sub is not equal to 0. So the mean is not the same. So that's the final conclusion. So after or before viewing, so this the video did had an effect for that. So let's read the conclusion. Reject H1 mu sub d equals to 0. There's sufficient evidence to warrant the rejection that the claim that the mean is the same before and after. So we have enough evidence to warrant the rejection of HO that says they are the same. So what we put, we said the mean is not the same before and after. So all right, this is sample exam number 4A. Again, please, well, yeah, I know you watched those videos, not try to do it yourself, and then after that check the solutions again and see how you do it. It's not enough, watch it 2-3 times, and I'm sure after 2-3 times you'll be very comfortable with that. All right, thank you everyone, and I'll see you soon in the next video. Bye bye.